Welcome to all. In this session, we have to study of semiconductors. The overview of this session is what is mean by semiconductors and what is band gap and valency band and conduction band. What is mean by holes and electrons in semiconductor and how what mobility of their holes and electrons and the types of semiconductors and the properties and applications of semiconductors. First, semiconductors are nothing but these are the materials which have a conductivity between the conductors and non-conductors or insulators. We know that conductors is nothing but they are allowed to pass electric current with them, and non-conductors is nothing but they are does not allow the electric current with them. Some examples of semiconductors. First, in compound state, gallium arsenide is an example for semiconductor, and in pure element, germanium and silicon. Band gap is nothing but it is the adjacent band representing the range of energies that possess no electron. That is called a band gap. In this band gap, there are two bands. That is a conduction band and valence band. This is the energy gap between the conduction band and valence band. That is called as a band gap. In conduction band has electrons. That is a negative charge particles, and valence band had holes, that is a positive charge particles. We know that valency bands and the conduction bands, the valency bands are the highest occupied energy band and they are the lowest unoccupied energy band. Compared to insulators, the band gap in semiconductor is very small. It allows the electrons in the valency band to jump to the conduction band for receiving external energy. In conduction band, it has holes and electrons. The holes have a positive energy level and electrons are the negative charge carriers. So these are nothing but these are the charge carriers in flow of current in semiconductors. Holes and electrons are the types of charge carriers accountable for the flow of current in semiconductors. Holes are the positively charged particles and the electrons are the negatively charged particles, but they are in equal in magnitude but opposite in polarity. Mobility, that is movement of electrons and holes. In a semiconductor, the mobility of electrons is higher than that of holes. The main difference is the band stretches and the mechanism. Electrons travel in conduction band, whereas the holes travel in valency band. When we applied the electric field, the holes cannot move freely like electrons due to this restricted movement. Concept of electrons and holes. Listen, here we have to SI, that is a hole and free electron. Holes are the positively charged particles and electrons are the negatively charged particles. These electrons can be tried to move to positive side, that is to valency side, when we applied the electric field. Then types of semiconductors. Semiconductors are classified as two types. One is intrinsic semiconductor and another one is extrinsic semiconductor. Intrinsic semiconductor is nothing but that is a pure form of metals. In this type, we cannot add any type of impurities. For example, germanium and silicon. In extrinsic semiconductor, we have two types, that is the N type and P type. In N type, we have to add pentavalent impurities, that is phosphorus, arsenic, antimony, etc. These are the donor impurity. And P type, in this P type, we have to add trivalent impurities, that is a gallium, boron, indium, and aluminium. Intrinsic semiconductors are made to be very pure metals, and extrinsic semiconductors we can add some suitable atoms, that is called as impurities. The process of adding impurities to the pure semiconductors is called as doping. What are the difference between intrinsic and extrinsic semiconductors? Intrinsic semiconductors are the pure form of semiconductors. In extrinsic semiconductor, it is the impure form, so we can add some impurities. The density of electrons is equal to the density of holes, and here it does not equal. The density of holes and electrons are not equal. Electrical conductivity is very less in intrinsic semiconductor, and in extrinsic semiconductor, electrical conductivity is very high. There depends only on temperature. There depends on temperature and the amount of impurities what we add to the semiconductor. Here no impurities present. Here trivalent band impurities and pentavalent impurities are present. What are the properties of semiconductors? They are act as insulators at 0 Kelvin. While we increasing the temperature, they are working as a conductor. So they are allowed electric current and temperature with them. Due to their exceptional electrical property, they are modified by doping to make semiconductor devices which can be suitable for energy consumption, switches and amplifiers. So we can add as a semiconductor device. They are less power losses circuit. They are very small in size, and so in small size they have less weight. The resistivity is higher than the conductors but lesser than the insulator. While we increasing the temperature, the resistance of the semiconductors will be decreased. Suppose if we decrease the temperature, the resistance will be increased and vice versa. Applications of semiconductors. Semiconductors plays a major role in many fields. They are used as a temperature sensors with the sensor devices, and they are also used in 3D printing machines, used as a microchips and self-driving cars. They are also used in the calculators, solar plate computers, mobile phones, and other electronic devices such as smart watches like that. Transistors and MOSFETs used as a switch in the electric circuit are manufactured using semiconductor. Transistors and MOSFETs are used in switch. They are also made up of semiconductor materials. Thank you.